How's it going, everyone? Welcome. Elmer Gonzalez here. And yes, let's take a look at the course taught by Matt Pocock, software engineer that previously worked at Vercel, a software company hosts now React and provide Next as a framework, and also, well, I don't recall what is the name of that service that it provides, but it's similar to others like Netlify, aka they want to automate the deployment of your web app by using is this CI/CD and offer that to their clients. So you just provide their repo, and they're gonna now pull up all of that, and they're gonna pull that code, verify that is installed and built properly, run the tests, and if everything went well, deploy that right on their own service. This is the business model for a lot of these hosting service providers. So right now, what I'm doing is looking at the Typescript, understanding is the origin of the language, which is come up with a bunch of engineers at Microsoft back in 2012, when if you're writing web applications in JavaScript, this is great for rapid prototyping, right? But when it comes to now scale that and maintain across different team members and groups or pods, it becomes quite hard to debug, detect errors, especially if that happens at runtime. So you don't have any, so the heuristic here, the forensics, becomes quite hard to spot on, and also to do a refactor in your code because since the JavaScript dynamic nature is not giving you hints about the shape of the data, you have to figure it out by yourself. So this is all of the problems that bunch of engineers at Microsoft have to deal with it, because they wrote programs with C Sharp, and I really my small experience with C Sharp is or was very interesting, because now I can see the data, I can see is the type annotation of the data at that specific point. So making it so throwing errors at build times is much more easy to debug and fix them rather than runtime. And also it come up with some refactoring tools that makes our life as a developer much more easy and to ship more, allegedly, right? So now the language known as TypeScript right now, it all begins with a codename script hash or script shard. Okay, so understanding this, a little bit of history of how do I get here, and how now we write programs in JavaScript. So you just only have your JavaScript files, and that is going to be executed in this one of those JavaScript environments, or specifically the ECMAScript environments. So they now take your code, they parse it, and they tokenize your code, they parse it, and instead of generating code, they execute that, right? Which is what happened in compile language. But again, JavaScript doesn't behave like a true compiler language or like a true interpreted one. So now it sits on between, and particularly is how JavaScript analyze the code, early errors, hosting and syntax error. So it behaves like a compiled language when it analyzes the code, not when it generates it, right? So this is when Typescript kicks in. And you have now two phases here. I will broadly describe that as two phases. The first is that on the development. So you write your Typescript code. Those are watched by a server that provide you some hints in detect errors at build time, right? That they provide you some hints. So they provide you some hints of errors and detects the errors that usually we use an ID, these integrate development environments to run our code and to check that. And once you wrote your file and it is ready to be delivered, it passed through the compile phase, aka it's going to generate now Typescript code into JavaScript. This is known as transpilation. It's a fancy word that say, hey, I'm going to convert one program in a high-level language, aka in a human-like readable language, into code into another human readable language. In compilation is that instead of transforming from one type or high-level language, whether it's Python to Rust or to C#, Ruby, yada yada, something that we as humans can understand is going to now generate a portable binary execution, something that now machines can understand, as long as you live in a particular platform, right? So whether it's on Windows or the myriad of these Linux distros, or even in Mac as well. And you also have now Huawei and some other forks around Android and Linux distros. So this deployment, which is made by the compiler, it is something that you can specify what are the JavaScript outputs you want to generate, right? And because the spec of the ECMAScript spec, some usually from 2015 to now has shipped spec, aka new proposals to the language every year. So now we have all of these different JavaScript versions that we can generate. And right now, after I went through understanding these two different phases, the development and the compilation, now I actually have some real feedback from it, right? And I do the work. So that is, hey, let's go to look at how now particular programs behave when you write in plain JavaScript or when you write is with Typescript, and what are the things that we need to do with Typescript, how you can compile from one language to another, what are the things that we're going to use here, which is a Visual Studio Code, the PNPM instead of NPM, which is a package manager for Node applications that are written in JavaScript. Also the Node environment. And Typescript, here the compilers, as I mentioned before, I can specify is the version of, so the ECMAScript spec output that it can generate, right? So after that, right, because I install is Typescript as an npm package, it provides a binary code that actually compile our code. And first we need to initialize is the configuration file. This configuration, I see that it change across versions. And I think of this, or if you think of this, is because now the new spec of JavaScript actually is shipping things that are very specific to that um, version. Now, in other words, because here we just using is Typescript 5.2.2. Right now it is on 5.9. We have 7 minor versions, but again, the Typescript itself is continuously adapting. You have also another transpilers. One of them is written in Rust, known as the SWC. So it's a speedy web component, right? You also have Babel and others as well. So SWC is heavily used on Vercel, this company that I mentioned at the beginning of this video. So, having said that, let's get into this to the new or to this automatic compiling, automatic Typescript compilations. All right, let's dig in. Deconvert Typescript into JavaScript. Exactly. Diggy. And here we are, right? So converting a automatic Typescript compilation. So automatic Typescript compilation.
In this exercise, we're starting from where we left off from the previous exercise. But this one, we're...
Okay. So in this exercise, we started from what we left.
In this exercise, we're starting from where we left off.
Okay. This is also why I'm taking notes out of this. In this exercise, we're starting off where?
The previous exercise. In this exercise, we're starting from where we left off from the previous.
In this exercise, we're starting when we leave off. I am.
Exercise. In this exercise, we're starting from where we left off.
Okay. In this exercise, we're starting from where we left off.
The previous exercise. In this exercise, we're starting from where we left off from the previous.
We're starting from where we left off in the previous exercise. Okay. In this exercise, we're starting from where we left off in the previous exercise. But it's interesting.
In this exercise, we're starting from where we left off from the previous.
He's using starting, but the recommended is we start from where we left off. In this exercise, we start from where we left off. Okay.
Exercise. But this one, we're trying to make our development process a bit better.
Okay. But in this, we're trying to make the development feedback loop better or faster. Say faster.
The way it's currently working is we're basically having to, every time we make a change inside here, we're having to run tsc in order to get the new JavaScript file out. Then we can open it in the...
Exactly. So the way we have the way I have things uh, from the previous exercise is that anytime we make a change, we need to use or we need to run is the Typescript Typescript compiler, and to run is a Typescript compiler to output.
Currently working is we're basically having to, every time we make a change inside here, we're having to run tsc in order to get the new JavaScript file out. Then
we need to run the Typescript compiler in order to get the new JavaScript files out.
Then we can open it in the browser and check that what we've got is real.
And then open up the browser and
Also, to every time we make a change inside here, we're having
exactly. So the way I have things from the previous exercise is that anytime we make a change, anytime a change is made, we need to run. Exactly. Anytime a change is made, we need to run as a Typescript compiler in order to get the new JavaScript files out. Okay. And then opens up the browser.
Having to run tsc in order to get the new JavaScript file out. Then we can open it in the browser and check that what we've got is real. So if we
And then open up the browser and check out. And checks out.
say hello world inside here, gotta run tsc again, then I go inside here and it says hello world. Great. It would be great if we could automate one of the parts of this, which was running tsc. Your job is to work out if there is a continuous watch mode that we can use with TypeScript in order to make sure that whenever our TypeScript code changes, our JavaScript code also gets emitted.
So here, whenever a Typescript file change, we want to automate that process so we can see. So we want to automate that process. And here now the compiler has a watch mode.
Good luck.
Right? The compiler has a watch mode for that, right? And you can take a look now to get myself familiar with this Typescript. All right. JavaScript and more. The handbook is this one, the get starter. Typescript for new JavaScript. No, but this is exactly Typescript tooling. Here you are. Here, there you go. Build your first TypeScript, compiling your code, type annotations, interface, and classes, and running your TypeScript web app to do so as it is. Yes, but in my case is looking more at the project configuration, the TypeScript CLI options here, like this, right? So you have now show all compilers options, flags, build options, watch options, compiler flags. Okay, there's a lot of compiler flag. There is a lot of compiler flag. Okay. Interesting. It is. Learn how to use the TypeScript.config JSON. project configurations. Okay. So the presence of TypeScript.json file in the directory indicates that the directory is the root of TypeScript. That the directory is the root of a TypeScript project. The tsconfig.json file specify the root files and the compiler option required to compile the project. Okay, two things that is specified, yeah, right? This TypeScript configuration is what are the root files and what are the options to generate or to compile the projects. So JavaScript projects can use json.config, a file instead, which act almost the same but has some Java related compiler flag enabled by default. A project is compiled in one of these following ways, whether it's using the TypeScript config.json or a JavaScript config.json. JSON is a notation that we heavily use now to describe its policies, or to describe is a state of information, a bit of information that is relevant for a context. In this case, to describe configurations. So you can also have is other type of JSON that describes different piece of information. And I mentioned policies because in the case of AWS, when you use one of the servers to access to the myriad of their servers known as the IAM, right? That allows you to create now users and groups and provide policies or allowed to provide is permissions. Okay, following is now a specific JSON structure. So these JSON structures, at the end of the day, they are specifying is that information, right? They represent is this piece of information. Okay, good. So by invoking the TypeScript compiler with no input, in which case the compiler search for the TypeScript config JSON and file starting in the current directory and continuing up the parent directory chain. By invoking TSC with no input files, exactly. So by invoking TSCs, the compiler with no input files, in which case the compiler search first the TypeScript config JSON, starting in the current directory and continuing up the parent directory change. By invoking TypeScript with no input files and project flags, you can specify is the directory, okay, or just be command line that specify the path of a directory containing the TypeScript JSON files, or a path to a valid JSON file containing the configuration. Either way, the compiler needs that piece of information in a JSON object to actually now take the source code as it mentioned here, or take the root files and the options to compile the project. And this looks like this. So you now have the compiler options, and then you specify is the file that it wants to, the source files or the root files, all right? That you want to generate respective JavaScript output. You want to generate a JavaScript out or to get, all right? Exactly, to get the new set of JavaScript files out. Exactly, is to get the new set of JavaScript files out. Okay, using the include and exclude properties, okay, you can also have them. But again, this is the basic example of this, right? So now things are starting to, okay, I'm get familiar with this. Hey, what is the model? Not implicit any, remove comment, preserve cons enums, and source map. and Typescript config bases. Depending on the JavaScript runtime environment which you intend to run your code in, there might be a base configuration which you can use in the config bases, and these are these are configs files which your project extends from, which simplifies your Typescript config JSON by handling the runtime support. So for example, if you were writing projects using Node.js version 12 and above, you could use the npm model tsconfig 12. Okay. So in other words, it's now using their config bases here. Holy moly. Host tsconfig to extend in a Typescript app tuned to a particular runtime. Okay. Hey, what is the runtime that you want to run? You want to go? This is the Typescript config file. Oh, okay. So if you're using Vite with React, this is the Typescript config. Okay. Okay, can I look at this? Okay. Okay, and it is specifying it with that React Native, Vite, interesting. QGS, React Native, Remix, Strictness, Vel, Taro, Vite, React, like this, right? Makes a lot of sense. Can I take a look at that configuration? And this is it, right? So here is specifying is the schema.typescript JSON. Go to this. Oh, am I going to download it? Right? Really? Okay. No, I just wants to go to that. Oh, you're hosting all of these config files. Interesting. Okay, makes up my mod. Oh, Jesus. JSON scheme store. Okay. Public API JSON. Okay. Premium sponsor Microsoft JetBrains and your business. Okay. Okay. Makes sense. Makes sense. Vite React version 7.00 in compiler option. TS build in info file in target. So here is describing is the options. Okay. The Typescript build into files, the target that is using, look at this, it is using is the ES 2022. So allegedly, according to the base JS config, the base Typescript config file provided by the Typescript organization, it say, hey, let's go to now, so browsers up to, so in 2025, most of them understand now ES6 2022. Okay. All right. Model ES next, skip link check, and bundle model. Okay. It also provides you now model bundler options, model resolution bundler, model thing, detect that this is a GSX, and then linting here. Okay, that's okay. Revealing, by the way. In the case of React Native, you have now a different configuration here, right? It say, hey, let me target ES next, common GS, types from React Native and Jest, so it actually built in that testing library. This is all the library that I want you to use that are available on this project. Look at this, and it's very specific: begin, date, number, promise, string, symbol, well known, promise, string. All of these are part of this spec. And allow JavaScript. Interesting. JavaScript no emit, isolated model, strict model resolutions, ES model interrupt, skip list check, and you get it. Okay, that is It's actually revealing. Revealing, my friend. Revealing. 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 Okay. Uh, so the other is with Remix, right? Remix also is using our GSX because it's this web framework pretty is this web development framework of React apps, right? This is why the configuration is more is smaller. Even it's now is targeting is ES 2019 or 2022. Like for example, is Vite here, the Vite configuration, right? Is targeting now is this. So okay, all right, okay, good. Now project configuration. What is a TypeScript config JSON? So if you want to, this is compiler options in MS Build. Oh, when you have an MS Microsoft Build based project which utilize TypeScript such as ASP.NET Core project, you can configure TypeScript in two ways, either via tsconfig or via project settings. This is if you are writing applications in that domain, but in my case, no. So no problem. This is the TypeScript config reference. All right. Again, you're going to specify is the files or the root files and the compiler options to get the JavaScript out. Okay, to get the new set of files, to get the new set of JavaScript files out. Okay, this is the okay. Here is how to use the CLI command. Okay, so running TypeScript locally will compile the closest project defined by the TypeScript config. I'll be right back. Is it the wrong compile based on back? No. So running TypeScript locally will compile the closest project defined by TypeScript config.json, or you can compile a set of TypeScript files by passing in a glob of files. What is a glob of files? In programming, is a libc, is a standard library. Okay, it's a libc function for globbing. What is a globbing? Which is the archetypal use of pattern matching against the names in a file system directory. Okay, pattern matching. Pattern matching against pattern matching against names in a file system directory. I can use a glob such that the name pattern is expanded into a list of names matching that pattern. Although globbing may now refers to glob style pattern matching of any string. Now use expansions is just a list of file system names. The original meaning of the term is still widespread. It's a pattern matching against names in a file systems. Right now we use glob as a pattern matching against strings. Okay. A pattern matching against files name. Against names in a file system directory. You want when input files are specified on the command line. All right. So when input files are specified on the command line, TypeScript config.json files are ignored. Okay. So this is now going to look up for, if you don't specify anything, it's going to run run a compile based on a backward look through the FS for a Typescript config JSON. Okay, gonna compile this based on a Typescript config. I only going to generate is one JavaScript file with the default compiler options for this file. I'm going to now emit a series of JavaScript files from these folders with the default settings. I'm going to look now at the project. I'm going to emit files reference with the compiler settings from the config dot from Typescript from tsconfig production.json, and I'm going to emit files, emit the definition files for a JavaScript file with showing compiler options, which are booleans here. Okay. Emit a single JavaScript file from two files via compiler options. Exactly. Emit a single JavaScript file. Okay. With from two files via compiler option, which takes strings arguments. This is the use cases here. So right now I'm using is. Can you see what I'm looking right now? There you got it. Okay, makes sense. Or whether it is run the compiler with the diff by looking at the config JSON, or by looking at the config JSON, yeah. Or generate or emit one single file with the compiler defaults, or generate a set of JavaScript files with the compiler defaults under this folder, or generate now a files that reference these project configurations, or generate is the Typescript definition file from this JavaScript file, or generate a single, in this case, or generate a single JavaScript output from two source or from two files via compiler options here. Okay. CLI command here. So you got is the flags local. So set the language of messaging from Typescript. This not affect emit. Interesting. You can set the locale. Okay. All right. That's the locale, really. All right. Okay. You can set the locale here to a string. Build options. Build, clean, dry, force, and verbose, and watch options here. So exclude directory list, exclude files, and you can watch input files. You can also specify watch directory, use FS events, fixed polling interval, dynamic priority polling, and fixed chunk size polling. Specify how directories are watched on systems that lack recursive file watching functionality. And watch files. Specify how the Typescript watch mode works. And specify how directories are watched. Okay. Specify how directories are watched on systems that lack recursive file watching functionality. Okay. Interesting. And specify how Typescript watch mode works. So there are systems that doesn't have or that lack recursive file watching. Okay. Anyway, and then the compiler flags. exactly all the compiler flags that you can specify here. Okay. So here I'm going to is do this. I'm gonna create now a new fork out of this. Let's say git um, git git branch, because I do want to get is all of them. So you got is the main. That's right. We get as main. And here what I do want to do is this is now compile Typescript to JavaScript. Compile Typescript to JavaScript. Is this one. Okay, is the watch mode. Is the watch mode. Is the watch mode. There you got it. Is this one. Okay, is the watch mode. Okay, so let me is git switch to main, pull it, git pull origin main. So pull me the latest changes. Say, hey, I don't have access, right? Because I misspelled that. There you got it. And let me now create is a branch called this. Okay, with these new changes, and I do want to navigate to 012. DS watch mode problem. Here, now that I do have, that's right. You look at that. So now that I do have is here this config file, okay, that was generated for me, and unfortunately this doesn't tell me is which version generated, right? Renovate JSON. It doesn't tell me that. It doesn't tell me that, man. Yeah, it doesn't tell me that. This is the compiler option, and you can also specify the file here. Okay. So why this is important? Because with this, so specifying the Typescript compiler version, you can is not only use the new features or to fall back to a more safe compiler, right? To a more safe version of the compiler. But in any case, so is this, right? So it actually targeting is the ES 2016. As you can see, the config files for React Native or other, they are not using is this. In fact, they're using is 2022, the ES6 2022. All right, it's using the CommonJS, right? Specify what model code is generated. Is the interoperability with ES model interop is true. The other is a strict. Enable all strict type checking options. And skip leak check here. Exactly. I'm gonna skip leak check here, which is true. Skip type checking all d.t.d.ts. Okay. Ignore all of it. Okay. Okay. Ignore all of the checks in definition files. All right. So if I do this, say, hey, Typescript compiler, on this folder, Typescript compiler on this folder, and say watch, right? Now, anytime it actually generates this piece of file, I can now is actually doing so. Okay. So if I now copy the full path, copy full path, copy relative path, copy remote file URL. Open change, open on the remote web. If I say copy relative path, if I say copy path, it's gonna give it to me is the full path? Yes, it will. So go back to the browser, open up a new tab here, and when I inspect this, I have the hello. So if I modify, for example, is that example to say hello world, and I save that, it generate that, I reload that, I have this, right? So now I skip is one phase of the, so I automate that phase for me. Anytime that this file change, is Typescript will get a new JavaScript files out. So I don't do that. I don't have to do that manually. The only thing that I have to do manually is, well, the refresh, right? So I don't have right now any server listen for events and serving the content here. Okay, okay, all right. Pattern matching. All right, all right. That was pretty straightforward.
The solution here is really nice. Inside the proper directory here, I'm going to run tsc --watch.
--watch dash dash, right? So it starts with a problem and a solution. And problem solution approach. Yeah, use the Typescript compiler to run, or use the Typescript compiler to get a JavaScript files out. And then opens up opens up the browser to check out the changes. Right? So in the solution here, it is quite nice. We get, yeah, exactly. So the compiler is watching for a file to change in this directory and emits a new JavaScript file, emit a new JavaScript files out, is watching for a file to change and emit a new JavaScript files out. Yeah, that's it. The whole magic
And
of
now, if I look at this, it's saying starting compilation in watch mode. If I open up the example.ts and the example.js, you'll be able to see that when I make changes to the TS, so I say hello world here, it automatically goes through to the example.js here. Now, this TSC watch mode is really, really nice because it's going to check my entire project for me too. So for instance, I add in, let's say, a wrong thing here, or I say message number, for instance. Then if I save the file, it's going to catch up with me and it's going to say argument of type string is not assignable to parameter of type number. Look at this. So this is really nice. TSC Watch gives you basically a way of checking your entire project every time you make a change inside there. And so if I change it back to message string, it's now going to work. And then if I go over to my browser, I can see that when I refresh, I'm going to see hello world. So TSC Watch is a really critical tool to know about, not only because it means that you get to skip over some parts of kind of like running TSC every time, but also because you can use it as a way to monitor the status of your entire project and make sure there are no errors across the whole thing.
All right. So the use cases is Typescript compiler is a use is sometimes so sometimes we need to skip some parts of our check-in. Okay, so it is useful to know about it, and also okay, to skip some part of the compilation that we don't need to. Yeah,
The solution here, so TSC Watch is a really critical tool to know about, not only because it means that you get to skip over some parts of kind of like running TSC every time, but also because you can use it as a way to monitor the state.
Okay, so TypeScript sometimes we need to skip some part of our check-in process, so it is useful to know about it, and also for monitoring our entire app for errors. Or hints.
Of your entire project and make sure there are no errors across the whole thing.
Across the whole thing. So TypeScript compiler, sometimes we need to skip some part of our checking process, so it is useful to know about it, and also for monitoring our entire app for errors or hints. To monitoring our app for errors or hints on the whole thing. The whole thing. On the whole thing, but when they say whole thing, is like in Argentina, They call this el coso. In Venezuela, they call this la vaina. In the US, they say the whole thing. The whole thing. The whole thing. Toda esa vaina. Okay. El coso. Alright. Okay.
We're now in a spot where we can run TSC watch every time we're developing and make sure that the JS files are always up to date with the TS files. But as our project grows, we're probably going to want to put the...
Exactly. Now we are in compiling Typescript files to a directory. Compiling Typescript files in a directory. Diggy. Compiling Typescript files into a directory. Compiling Typescript files to a directory. Compiling Typescript files to a directory. So the problem here, the problem and solution approach.
JS files in somewhere else, right? It would be great if we could put them inside a directory so that they weren't just cluttering up our TypeScript files here. Your job is to work out how we can change the tsconfig.json, change something inside this configuration file in order to make this happen. What we want is we want a folder called dist, basically. So I just imagined this folder here called dist. This is where all of our JavaScript files are going to live. Dist is kind of like distributed code, basically. And we're probably going to need to change the gitignore to just gitignore the stuff inside dist as well, because we definitely don't want this committed to Git. We're also going to need to change the index.html to make sure we're referencing the new files. And yeah, see if you can find the tsconfig.json setting which makes this change happen.
In here is this. Exactly, so now I haven't changed anything here. Alright, there is no change here. It's just now using is the watch mode problem. And when I switch this, or in this case get switched to main, alright, and then I go to the compiling to a directory. Oh, I can do this? Much better. Oh, it's because I am not here. Alright. Here I can say get switch to this. Alright. And what I do want to do is to create now a folder to do so. Compiling to a directory problem. Exactly. Compiling to a directory problem.
Good luck. We're now in a spot where we can files, but as our project grows, we're probably going to want to put the JS files in somewhere else, right? It would be great if...
Exactly. So as our Typescript files, or as our project grows, we need to put it in some place to easily deploy to production, right? So how can we put all of our files in a directory to be later on used for production? Right? And the answer is by, well, let's check out the tsconfig.json to do so. And here, by getting myself familiar again with the Typescript config reference and enable is Typescript compiler options, type checking, models, emit, yada yada yada. I can now specify this is the output formatting, type checking, emit, JavaScript support, interoperability, backward, language compiler, projects, tiki. This is the watch options, and it must be one of this: command line, completeness, output formatting, project, compiler diagnostic, language and environment, backward compatibility, interrupts constraint, editor support, and emit. Yeah, it's on the emit. Okay, so I'm assuming that is no emit helper, no emit out there, and out file. Is about the out there here to say, hey, the out there, if it's specified JavaScript as well as the TDS and GS map, etc., will be emitted into this directory. The directory structure of the original source file is preserved. Interesting. The directory structure of the original source files is preserved. See root dir if the computer root is not what you intend. Root dir. The longest common path of all non-declarative inputs. If composite is set, the default instead the directory containing the tsconfig file as it is. So when Typescript compile files, it keeps the same directory structure in the output directory as exists in the input directory. Exactly. It keeps the same directory structure in the output directory as the input directory. That's interesting. For example, let's say you have this, and then it's going to generate now is a JavaScript file like this, right? However, you may have intent for core to be part of an output directory structure by setting root dir as it is to here in Typescript config JSON. Typescript will write this 3 as it is under the dist core. Okay, so if you want to specify is a different parent or a different folder structure from the source code, you might want to go with. That's interesting. Okay. So out there is a property that allow us to is a property that allows to specify the input Out there is a property that allows to specify is the output folder structure. Exactly, is the output folder structure exactly. It allows to define is the output. It allows to define the JavaScript files out in it allows to specify is the JavaScript files out to specify the directory to get the JavaScript files out. Right? Out there is a property that allows to specify the directory to get the JavaScript files out. Okay? Okay. By default, it keeps the same source directory. It keep the same source folder structure unless exactly, but you can change that. Okay. Hey compiler. Hey compiler, you know what? The output here, in this case is right. The out there will be now. Let me uncomment this. The out there will be now is this, and I want you to preserve is the source folder structure. The source code folder structure. So now if I go here and say, hey, let's go to this place, compile into a directory, all right? And I do want this to say, hey, let's go with these. I want to run here, right? It's going to generate now a folder for me that contains is that code that contains that JavaScript specific version code, and what else, and keep the same folder structure, and keep the source folder structure. And here what I do need to change is the this, right? So now when I change and say, hey, copy path, go back to the browser, and then I do this, right? I can see is hello, right? Silly, yet important too. Okay. Specify the output directory. Specify the output directory. Git pull origin of 013, and there you got it. Oh, git add everything, git status. there's a couple files that I don't want to include, right? And that is on the this. I don't want to include the this, right? At git ignore. Okay. Git status here, git log, right? And I can say git push origin to this. All right, it's going to create now the PR for me. It's gonna create that PR for me, right? Where now I can specify is that, right? So compiling to a directory. Using Typescript compiler version 5.2.2 here. But I do want is to do that to my own repo. Exactly. Thanks for keeping that. This is the only 2 chains that I want to add. Makes sense. All right. And now let's do this, right? Okay. That creates that a branch of my code here. Okay. And voila. Okay. Okay, get status here. I can switch to the main. I can pull the change from main. All right. And there you got it, right? Makes a lot of sense. Okay. All right. Okay.
We could put them inside a directory so that they weren't just cluttering up our TypeScript files here. And find the change happen. Good luck. So the start of this solution is to go into the tsconfig.json and look inside here and try to find the outdir. Outdir, out directory, specify an output folder for all emitted files. This is a really, really useful setting because it means you just get to organize all of your emitted code into one place. And we can also see that whenever we change the tsconfig.json here, if I close the right directory, then this will basically tell the TypeScript compiler, tell the TypeScript CLI what to do. So when I run tsc watch inside here, it's going to first of all create a dist directory. And then we have now an example.js in there. So if I look at my example.ts and then open my example.js in another file here, so we've got this one on the left, this one on the right. Let me pull this apart for you. We can see that when I change to hello Matt, for instance, then it's going to change on the right-hand side too. So this means you just get to be a bit more organized, and it also shows how the tsconfig.json influences the way that TypeScript works inside that directory. We've now got the makings of a very basic web app here. Very, very basic web app, where we can basically create some stuff in TypeScript and then...
Now this is the TypeScript use Vite for a front-end app with TypeScript. It is use Vite, right? Use Vite. use vid for a front-end app with Typescript. For a front-end app with Typescript. And again, it's following is the same format, right? Problem at the solution.
By running TSC watch, that will then flush through to the index.html. But we've now got the makings of a very basic web app here. Very, very basic web app, where we can basically create some stuff in TypeScript, and then by running TSC watch, that will then flush through to the index.html.
By running the TSC
watch, that will then flush through to the index.html. Create some stuff in TypeScript, and then by running TSC watch, that will then flush through to the index.html.
What does it mean with flush, my friend? Okay, so we got so we now got the makings of very basic web app here. Very, very basic web app, where you can basically create some stuff in TypeScript, and when by running TS watch, that will then flush through to the index.html. What is flush? Because this word keeps bothering me. I am not flush, to drive or to dart or fly from cover. Flush, to fly away suddenly, or to expose or change or chase from a place of conceal. A handy play. Okay, if you use as a noun or as a verb, it's flush out, it's fly away, to expose or chase from a place of conceal, to cause a beard to flush. But if you use that as a noun or as a verb, to flow and spread suddenly and freely, to glow brightly, to produce new growth. To produce new growth, interest, to cause to flow, to pour liquid over. Flush it. Okay, to pour liquid over or through. To pour liquid over through. Holy fuck! Especially to cleanse or wash out. Okay, to flush out. It's like to pour in something. Flushed along with air is to pour something over, or exactly, is to pour liquid over or through. Okay, pour over liquid or through. So I flush out. So I flush the toilet. So in other words, I clean the toilet, something like that. Exactly, especially to cleanse or wash out with or as if with a rush of liquid. Exactly. So I pour the liquid over or through, especially to clean up. Oh my god, to flush out. Yeah, so when I restart the server, it flush out. So it's like in a new state. Okay. Okay. Or it cleanse, it wash out. Okay, Jesus, French stuff. Exactly. So by running TypeScript watch, that will then flush through the index.html. It's going to create. It's going to cleanse things through the index.html. Holy fuck! But of course, there is an issue, which is that every time we make a change inside here,
by running TSC watch, that will then flush through to the index.html. But of course there's an issue, which is that every time we make a change inside here, we still need to refresh our browser on the other side.
Exactly.
So even though we've, with the watch mode, we've said, okay, we no longer need to run TSC every time, we're still going to need to refresh the browser every time we do it.
Exactly.
We're also not really set up to bundle things for the web, really. Bundling for the web is an extremely complex thing, and handling CSS, handling images, handling all sorts of stuff, we're just not quite ready for it. So in order to fix all of these problems, we're going to basically set up a front-end app with Vite. Vite is one of many, many front-end frameworks you could choose, but for this exercise I figure it's simple enough and should make sense to you in terms of what we're trying to do. Your job is to go onto Vite's website, which I'll link below, and basically set up a new Vite app. And that Vite app is going to really just run vanilla JavaScript, and it's going to use TypeScript as well. Vite has really great support for TypeScript, and basically it just works out of the box and we don't need to do any additional setup. It will give you a tsconfig by default, and it will also give you some various instructions, installation instructions, all that stuff. So Vite is a really great first step for anyone who's looking to get started in web development. So yeah, your job is to walk through the Vite quick start, create a new vanilla JavaScript and TypeScript app, and I'll see you on the other side and I'll show you my version also.
To flush the toilet, flush with pride, inflame, excited. Okay. A ruddy healthy color, full of life and vigor. Stream flush with springs runs out, lusty and abundant. Flush, in a flush manner. Cabinet set flush, or in a verb, to make flush. Okay, but this is to pour some liquids to flush things out. Okay, so I flush, or to produce something, or to cause. So to produce something new, or to produce new growth, or to cause to flow, to pour liquid over or through. Especially to clean or to wash out. Okay, so the TypeScript watch is every time a file change, it flush. Okay, it flows through the index.html. It flush through the index.html. Okay. It flush through the index.html. Okay. It flush through the index.html. Okay, so it creates now a new file, and it creates a new clean JavaScript file. All right. So it cleans up the old JavaScript files with this new one. All right. So it flushed the HTML index. It flushed through the index HTML. Okay. It's like flushing, inflammate, produce, or to wash out. Okay. It wash out. Okay. It wash out through the index.html. Okay, but okay. Because okay. It flush through the index.html, or it wash out here. Okay. So exactly. So anytime a file change, by setting the watcher, by setting the TypeScript compile, the by setting the Typescript compiler. So anytime a file changes, or by setting the Typescript compiler watcher, or by setting the Typescript compiler to watch for file change. Okay. So by setting the Typescript compiler to watch for file changes, it will flush out. Okay, it will flush. It will flush. It will flush through the index.html, but we need to manually refresh our browser. Okay, so I create a basic, I create a very basic so I create a, why is that? Stop it, bro. So I create a very basic, because it's a very basic web app, right? By setting the Typescript compiler to watch for file change, it will flush through the index.html, but we need to refresh our browser manually, and this is tedious, bro. And we also really need to set up bundle things for the web. Exactly. Not only this. Yeah. But we need to refresh our browser manually. Exactly. And bundle things up for production. And bundling is a very hard thing to do. Bundling for the web is extremely complex. So bundling for the web is extremely complicated. Extremely complicated. Because you have to handle in CSS, image, and all of that, and all sort of stuff we are not quite ready for. Exactly. So we need to handle. So you need to handle is CSS and assets and images and all of those, in all sort of things, right? And all sort of things. So in order to fix all of these problems, we're going to basically set up a front-end app with Vite. So to solve all of these problems, we are going to set up things with Vite, right? It makes a lot and a ton of sense. Mm-hmm. Okay. Mm-hmm. So that'll be all for this video. Take care. Bye bye.